Hello. In Investigation 6, called It's About Time, we now switch gears. Students are now going to explore a very abstract concept, and that is the geological time scale. This is something that can be quite difficult for not just students, but adults to really kind of get a grasp of in terms of the enormity of the timescales that we're talking about relative to the human lifespan or human history. However, I feel that this investigation does a really good job giving students at least a good concrete introduction to just what sizes in terms of time we are talking about. The investigation takes a little bit over a week, and it comes in four parts. And it starts off with students creating their own personal timelines, and then moving on to make different versions of the Earth's timeline. It starts off with a personal timeline. The students, by this age, are very familiar with timelines or with number lines, but they're used to going with these number lines and timelines going in a certain direction, with perhaps the present starting at zero and then going into the future. With a personal timeline being modeled after the geologic timeline, they're going to be looking into the past. So there's an activity where you start off with zero being today, and they have to calculate backwards in time major events in their life. For some students, this comes very easily. For others, it takes a little bit for them to shift gears. But eventually, they all pretty much get it. And the idea is for them to see that what we're doing is we're starting off and we're looking into the past. And each of these numbers on the timeline refer to number of years ago, number of years in the past, because that is then going to lead to them making a very large timeline with you and the rest of the class. What you see here is an item that comes in the kit. It's a Mason line keeper, and that is 45 meters of rope with a rope holder or a Mason keeper that comes with the kit. You're going to have this rope stretched out, and I'll talk about space issues in a moment. And students are then going to be posting, with your help, they're going to be posting major events in the Earth's history on this 45-meter timeline. What you see here is pretty much what the kit talks about. The major events are listed, and in the lower left-hand corner is the equivalent in distance on that 45-meter time scale. So, for example, if primitive humans arose about 3.5 million years ago, on the timescale where a 45-meter rope equals 4.5 billion years of Earth's history, that would be the equivalent of moving this card or posting this card at 3.5 centimeters from the 0 point. This presents an opportunity for you to actually do some math, integrate some math activities with your students, because for some students, this will be a little bit difficult. Again, you see here, 45 meters equals 4.5 billion years. Some students will know how to write 4.5 billion, some may not, so you may need to walk them through it like I have here on this slide. Others, you might be able to have them do the math themselves and let them calculate what the scale is, but eventually you want them to understand that 1 centimeter on that big rope is the equivalent of going 1 million years in Earth's past. And so for every centimeter we put a card, every centimeter we move back from the 0 point, we're talking about traveling back in time 1 million years. When they post all those cards on the timeline and they see the size of that 45-meter rope, they really start to appreciate what we're talking about in terms of when humans have existed, how long humans have existed, how long the earliest hominids have existed, when dinosaurs existed, when they went extinct, when they arose, when first life in the form of bacteria evolved, and so on. So it's a very good activity. However, there are some considerations. You do need to find a very large space. This is great if you have an outdoor space. You can have this line, 45-meter line, stretched out linearly. It would be great if you could tie the two ends to something. That way you can move with the entire class. Otherwise, it becomes an issue whether or not they can hear you from 45 meters away. I tend to do it in my school's auditorium. I'm not able to do it straight, obviously, but I have the line curve in a C shape. And I just have 4 students as helpers that hold either end of the line plus the 2 middle points. And that allows the students to be able to hear me, and plus I don't have to worry about it's weather independent. Lastly, the kit talks about putting paper clips into the certain points of the timeline that represent each of those distances you saw earlier. I highly recommend about a few days before you plan on doing this activity, stretch out this rope. Make sure, first of all, perhaps the previous teacher already marked it up for you, which would be great. If not, you need to insert these paper clips, and it's not necessarily the easiest thing to do. You kind of have to wiggle the tip of the paper clip around and kind of wedge it in to that Mason line in order to get them in there. So you definitely want to do that before you plan on doing this activity. Once the students see the big timeline, they're going to then go in and make their own individual or team versions of the timeline using a adding machine tape. They're going to be now reduced to a scale of 4.5 meters, which is much more manageable. And they'll have this worksheet with them where students will see the geologic eras and periods that you will already have talked about, what these mean and where these names come from, and what ages in terms of years ago or millions of years ago that these eras started or periods started. Then what students will need to do is they will need to calculate the distances that go on this 4.5 meter tape. So for example, today is 0 years ago, so it would be 0 millimeters from the starting point and 0 centimeters from the starting point. 1.6 million years ago would be 1.6 millimeters from the 0 point, or 0.16 centimeters. Obviously, the 1.6 millimeters is much easier to work with. And then just let the students work this out themselves. It might take some time for them to really work on this. Some students, this will be a snap. They'll see the pattern very quickly, and they'll be able to fill this out really quickly. Other students might struggle with this, so you definitely will need to monitor whether or not they can fill this out. What I tend to do is I have the groups work on this. Once they and their partners are all in agreement and I check it, then I give them the adding machine tape and they move on to the next phase. They take these numbers, and again, here's the scale. 1 millimeter is equal to 1 million years. Here it is again. You might need to work this out with them that now we're talking about a power of 10 smaller scale, and that eventually what we're talking about is every millimeter, which is about the width of a fingernail, represents 1 million years of Earth's history. They're going to take the adding machine tape, and this is a graphic that I generated for my class. I project this on the projector, and I show them what to do. And I recommend this. Don't have the 0 point be the end of the adding machine tape, because for some reason some students will struggle with this. They need to clearly see a 0. So what I recommend is you take maybe about an inch in or so on, and draw a line and say, this is 0. And I actually have the students put a little arrow saying 0 equals now. That also gives them some extra space to write their name and date and homeroom. And then what students will do is they'll take their sheet from here with all these numbers that they filled out, and now they can draw the lines. So there's the quaternary period, 1.6 millimeters from the 0 point. There's the beginning of the tertiary period, 66 million years ago, or 66 millimeters from the 0 point, and so on. And they'll do that for the entire 4.5 meter adding machine tape. It's a very good activity. It's a great way for students to incorporate math, measurement skills, but it definitely does require you monitoring their work. At the end, students will then go back to the rocks that they explored in the previous investigation. So let me switch to, this is a multimedia investigation that, again, you can find on FOSS's website. It's down the digital only resources, multimedia, Colorado Plateau over time, or it's also on the CD-ROM. And what it does is it allows you to go through and show students major events that happened, starting 1.8 billion years ago, 1.4 billion years ago, showing how there was the formation of the metamorphic rock, the schist that's at the base of the Grand Canyon, how there was an inland sea that then formed different layers of rock, how it continued by forming the different layers that you then see, and eventually get to the formation of the Grand Canyon as time goes on. Okay, so good luck. I hope you enjoy it, and I think you'll enjoy the activity.